Okay, everyone, welcome. Good morning, good afternoon, or good evening, depending on your location. Thank you so much for taking time to join us today. My name is Laura Record, and I am a lead solution engineer here at Tableau with about 5 years of experience here and another 12 or 13 years of experience at SAP prior to joining Tableau. Our focus today is on advanced mapping techniques, but before we get started, I need to give a special shout out to Ashwin Kumar. He's the product manager for our mapping technology. He created this content, but unfortunately just wasn't able to present it to you today. And so I am here in his stead to show you some of what's kind of cool about what you can do in mapping in Tableau right now. As a reminder, everyone here is currently on mute. If you do have questions throughout this session, please look for the Q&A panel to ask your questions. We do have some folks on the line who will be monitoring that Q&A panel, and it will be easier for them to find questions that are put there as opposed to questions that are entered into the chat, although we will try to get to both if we can. And many of the examples that we will go through today are step-by-step how-to exercises, but some of them aren't. Our primary goal here is not to teach you specific techniques, but to give you a broad look at what's possible for mapping in Tableau. We do have a lot of free how-to guides available online, and we have an extraordinarily active, engaged community out on the forums. If you're looking for additional resources to help answer questions or just see what other people are doing. We'll go ahead and kick things off here by connecting to our sample Superstore dataset using a saved data source. This dataset has been curated by our development team. It contains a good variety of fields and data, and it comes preloaded with Tableau Desktop, so it's always available to you. It's a great dataset to use for building examples or for learning and testing new functionality. In the data pane on the left side of the screen, we see all of our metadata, such as field names and data types, and we also see the kinds of data we'll be working with. We have information about our customers, about the orders they place, where those customers are located, the kinds of products they're interested in, and we also have quantitative values like discount, profit, and sales that we want to track. We'll get started by building a map, which is one of the easiest things you can do in Tableau. For any geocoded field, all we have to do is drag that field right into the view. Tableau is going to handle the rest thanks to our built-in geocoding database. As we drill in our hierarchy from the country to the state level, Tableau reevaluates what we are looking at in terms of the level of detail or the granularity of the data at this level, and it regenerates the geocode information, again, using that built-in geocode database. While we're at this stage, I'll show you something very quick that some people find that's kind of handy. If you need to export or look at or work with the data for just a couple states at a time, you can select those marks and then click the View Data button. That will show you both the summary values, and you can click on Full Data to see the list of all of the underlying rows that make up the selected 2 marks. One thing I want to point out on this screen is the evidence of Tableau using our geocoded dataset. We do not have any latitude or longitude data available in our Superstore dataset, but what we do have is a list of countries and states and cities that Tableau recognizes, and it can automatically generate the lat-long values for those locations. And that's what we see in the columns here. Back on our main screen, it's easy for us to change this map in its appearance. Right now, we're using circles to represent the rough geographic center of each of our states. We can change that by opening the list of mark types on the marks card and choosing the filled map option. Tableau again is using its geocoded database to fill in the shape of each of the states in our data set. And by dragging a measure to the color button on the marks card, We are then able to see a shaded map that shows the quantity of goods sold in each state. We can even add a copy of that same field onto labels so that we see those numbers. In just a few clicks, you've seen that we can build a very basic, informative map, but sometimes this isn't what we need. This is all driven off of the basic state information that we have in our database. But many companies use a custom sales territory, for example, and they need to visualize those in Tableau. So instead of looking at quantity of goods sold by state, we need to look at that by territory. So next, we'll take a look at how to use our lasso tool to create customized territories. With that lasso tool selected, I simply hover over each of the marks that I want to have in my West territory, and I'll group those together. I can continue this process for all of the other states so that I can create a North, East, there we go. And as soon as this is done, we'll create a South territory. All right. By selecting values and grouping those together, we've done a couple things. We've created a new logical object inside of Tableau, and we see that object over on the left side of the screen in the data pane. This is also an object that contains geographic information, so we can use this, as you've seen here, to add color to a map. But in just a moment, you'll see that we can actually use this to create a map all by itself. Over in the upper right, we have our legend. And that legend is telling me already that I have made a mistake and I missed assigning one state into our East region. For now, I'll go ahead and show you how to rename these values to make it easier for people to understand exactly what they're looking at. We want some user-friendly region names. Now we can edit those region names from the color legend. It's often faster to do that if you have just one or two values that you need to work with. If I want to start to make other modifications to this, I can edit the group that we've just built by going to the edit option for that group on the data pane. And right now you can see I've actually missed DC and Rhode Island. If I control click both of those, I can choose to add those to our East region. When I click apply, if you keep your eye on the color legend in the upper right, you'll see that the other option disappears with only 4 regions here that we have created with our custom territories. We also still have the number of goods sold by quantity here on each of our states. Because we are no longer restricted, though, to simply looking at the state or country level, because we've created that new custom territory, we can make sure that we show and aggregate data to that level by removing the state field. The territory information is contained inside of the group that sits on color, so we can aggregate data up to that level. Everything that I'm going to show you today is completely and fully integrated with the rest of Tableau technology. So I can continue to use that customized territory group in any view. For example, a stacked bar chart. We're still using the same information. We can take this customization feature even further. Instead of using Tableau's built-in geocoding database, I could pull in my own shapefiles and create custom territories off of my own spatial data. So in this example, we'll do exactly that by connecting to some hospitalization data. And this is going to look at Medicaid patients who are hospitalized in the state of New York. When we start working with healthcare data, a lot of the times we find that data is aggregated only to the first 3 digits in zip codes, and it's not broken down into the 5-digit zip codes that we're used to working with. This becomes a problem for Tableau. We know that this is a zip code field, so we have tried to apply the zip code geographic role to it, but the underlying data does not support that analysis. So we can use our custom geocode database to make sense of it at all. We'll work around this by bringing in additional data. We'll go ahead and add a connection to another Excel spreadsheet that contains a list of all of the United States zip codes. And once that connection has been established, we will join that zip code data to our Medicaid data. I'll bring out the sheet containing the zip code data from across the entire US. And we know we need to join this 3-digit zip code to some of the data that's inside our complete zip code list. Here's the problem. We do not have any data that matches between these 2 different spreadsheets. All we have in our secondary spreadsheet is a 5-digit zip code. So to make this work, to get a collection of all of the 5-digit zip codes that roll up to a 3-digit aggregation level, we'll use a join calculation. And that join calculation is going to use a simple string function. Give us the left characters from the 5-digit zip code, and we want 3 characters. Now this does contain errors, and that's because we're trying to use this calculation with a numeric field. It gives us the right result once we change that numeric field to a string. And now we'll change our 3-digit zip code to a string as well, so we can successfully join that data. Once our error indicator disappears, we can go back to our worksheet. And Tableau is going to, let me cancel this, and I'll clear that worksheet. I think I'll create another location hierarchy here containing all of our zip codes to make this a little bit easier to walk through. If I drag out just that 5-digit zip code, Tableau is going to create the workbook that we expect to see. And it's going to show a list of all of the, or rather a map of all of the zip codes that match the 3-digit code in our original Medicaid data set. And this is taking a little bit longer than I had expected. I think here, all right. Let me try that again on an existing worksheet that I've been working in already. See, there we go. So this is now a list of the original 5-digit zip codes. However, what I really want to do is have this available at the hierarchy level. So when I drag out the 3-digit zip code information, it is now successfully rolling up all of those 5-digit zip codes into the single 3-digit aggregation. I can drill down from the first level to the second level of that hierarchy if I want to see all of the unique zip codes. I could change the map mark type, right, to that filled map that we were expecting. I could even move the 3-digit zip code up to color so that we see that aggregation broken down by color as opposed to by state or by 5-digit zip code. And very similar to the last example where we created those custom territories, now that all of that work has been done to help Tableau understand how to interpret which 5-digit zip codes roll up to a 3-digit, I can now remove the 5-digit zip code from the analysis, and all of my data will be correctly aggregated at this level. If I then move that field to detail, so the context for this evaluation is still in the view, I can then add other measures onto color to start to identify hotspots, in this case, hotspots for hospitalizations. Right? And as expected, dense urban centers tend to skew that kind of analysis. So if I were to continue with this, I would probably start to do some filtering or apply any of those other Tableau techniques that are fully integrated with what we're doing with maps. We'll go back to my original worksheet now that that query has finally completed, because I want to show you next how we can start to expand on this functionality. We'll combine some of these mapping techniques that you've just shown, things like using a join calculation with additional calculated fields to get a better understanding of some of the data that we look at. So to show that example, we'll take a look at some census data. And in this case, we will be looking at census tracts in New York. If you ever see a lot of examples from Tableau about New York or sometimes Philadelphia or some other major cities, it's because they have a great structure for sharing data. So what we did is we found information about some New York data, and we've also found information coming from other public websites like the census, and we've downloaded the data sets that we need for this. The first of these is a spatial file, which is a new file that we haven't looked at yet. And that spatial file contains information about the US Census Tract locations. We've specifically narrowed this down just to New York to make it a little easier to work with. The other piece that we want to look at here is not just the census data. We also want to know who's moving into and out of those locations, because that's what we're really curious about. And to find that information, we can connect to some data that contains information about population mobility. I do want to show you something though first. If I go to a new worksheet and look at the census data that we just added, there's a new kind of field that comes in from that spatial data called a geometry field. In our case, that geometry field contains information about all of the census tract locations, and these are polygons. Going back into the data that we're currently working with for this analysis, I will add information for our mobility data. So who's moving into and out of these different census locations. Once the connection is established, I will join that mobility data to our census data. There we go. We have to specify the join fields because Tableau can't always assume that it knows which fields to join on. In this case, we can just do a straight, simple join from GeoID to GeoID 2. 2. And we see an error here. The reason for that is our fields are a different data type. So just like every other join that you work with in Tableau, it's going to request that that information be of the same data type. So for this, we will go ahead and change GeoID2 to be a string so that it matches the data type of the original GeoID field. Now that our join error indicator is gone, we'll jump back to our worksheet. And if you look at the left on the data pane, you can see we have a number of different ways now to track population mobility information compared to this census location data that we have. One of the things to remember about working with these collect fields is that when you first add them into Tableau, they actually create a single mark. So if I hover over anywhere on this map of New York, we can see that Tableau treats it as one mark. Right now, if I were to add any mobility information into this view, Tableau would aggregate it across the entire state of New York. In order to disaggregate this, to provide a deeper level of detail or a finer granularity to our analysis, we'll go ahead and break down our data by adding dimensions into the view. So if I add, I think it might be name on detail. There we go. It is not name. Oh, there we go, the GeoID field and not name. All right, so now we have a unique identifier for each of these individual census tract locations, and that's going to let us aggregate all of our mobility data to a specific census location. What that means is I can now find information about people who moved from a different state. And note I'm using the search feature there because there are a lot of different ways that we can look at this data. There we go. And now that I have that field on color, I again have this shaded choropleth map that lets me see hotspots. There are a few kind of down here in lower New York, and there's one that I find a little bit interesting in upstate New York. So I can zoom in on that location very quickly just by changing the zoom tool or the map tool that I'm working with to navigate. By going to our map layers, I can start to get more context around this without needing to add any other information or any additional data. When I add the outdoor map layer to this, you can see that I have a small airport here. The census area that we are looking at that has such a hotspot is Fort Drum, and it is right next to Beartown State Forest. I'll set that back to light and close out this map layers option and unpin my map to go back to my original zoom. Well, it turns out that Fort Drum is a U.S. military reservation that's home to the 10th Mountain Division. And that could be a significant contributing factor on why we have so many people moving into that single census tract. There's something else that's interesting on this map, though. If we were to go in and filter out all of those hotspots, we would start to see a lot more variation in who is moving into which location. But I want to see all of that hotspot information without having to go in and change kind of filtering or colors or things like that. What I would love to do, though, is start to do a comparison to see which tracts are getting above average or below average population mobility. So which ones have more people or which ones have fewer people moving in than the average across the state. To find this information, I'll create a new calculated field. We'll call that mobility, and I'll use the Control plus or the scroll wheel on my mouse to change the size of the text in that calculation window. And I'll write an IIF statement. If our total estimate of people moving from a different state, and remember I said we have a lot of different ways to view this. I happen to know that this field name that we are looking for just doesn't have the years appended to the end. So if that population is greater than, and next up is something called a fixed level of detail calculation. Most calculations in Tableau are driven in large part by the view level of detail. So what dimensions are in the view and what is impacting the granularity of this analysis that we actually see on the screen. Level of detail expressions allow us to manipulate that to some degree. Now I'll go ahead and fix this to the New York State level. Right now, we only have data for New York, but if we ever changed this data set to be more inclusive, we would want to make sure that we have that indicator in there. And I will look for the average of the population that has moved Oh, I picked the wrong field. Sorry, that's why I paused. I just realized this needs to be the different state field. Let me fix that very quickly. There we go. Moved from different state, not from a different county inside the same state. And to make things easy, I will be smart and I will copy that field reference. So I'll finish off the level of detail calculation. That simply says, for the state of New York, give me the average of people moving into any census location from a different state. So if the average for a single census tract is greater than the average across the state, then give us the words above average. Otherwise, give us below average. And I forgot my closing paren for that LOD. And I need another one up here. I'll tell you what, to make this easier, let's jump back to this worksheet because I've already created that calculation in the other workbook. And this is going, I don't know why it's not here. It was here just 10 minutes ago before I started recording this. All right. We'll jump back and I will do this the easy way, which means I'm going to go to my cheat sheet and copy this. There we go. So much easier. So that mobility calculation, if I put that on color, I start to see something interesting here. The dark blue locations have a greater than average quantity of people moving into them from out of state, whereas the orange ones are below average. I've lost all of the context from the hotspot information that we just saw, though. So one of the things I can do to get around that is to add mobility into the view without dropping it onto color so that the information is still there. And now if I look at that hotspot again, Tableau is pretty self-aware. So I can click on above average for the mobility result, and it's going to highlight all of the above average values. So far, the data that we've worked with has been pretty clean, and there hasn't been much need to go in and modify that to any great extent or to work too much with those join calculations that you saw. In our next example, we'll dig into a situation where the data that you need to combine is not quite so clean. To do this, we will take a look at some spatial data from Boston, because I want to start to take a look at Airbnb information across all of the neighborhoods in Boston. Now, this first shapefile just gives us an outline of all of the Boston neighborhoods. So I will go ahead and add in data coming in from Airbnb in this case. And it's going to contain, I believe it's an Excel file. Let me check, it could be a CSV here. The Airbnb data contains listing information for all of the Airbnbs that are located in the Boston area. There we go. Along with information about the owner and the unique ID for each of those. Now, normally, where I could, I would join on something simple. And for example, the name of the Boston neighborhood to the name of the neighborhood coming in from Airbnb. But not all data is that clean. Because we're working with spatial data, we have some other options here. You've already seen that geometry field that contains polygon information about the data we're looking at. So I can join that polygon data to spatial data coming in from my second table. The problem here is we do not have spatial data. But what we have is latitude and longitude. In this case, we'll use another join calculation. But our calculation is going to be a little different. We can take any data that can be represented geographically on a map and use that to create spatial joins. In this case, we need to have Tableau correctly interpret which locations of each Airbnb fall into the polygon, the outline of each Boston neighborhood. To do that, we'll use a function in Tableau called makePoint. This is going to create a spatial point based off the latitude and longitude values in our Airbnb data. We can use that spatial point information to relate back to the geometry information that is the outline of all of our neighborhoods. With spatial data, we have the ability to do an intersect. So Tableau is now going to take each neighborhood and find all of the individual locations that fall inside that neighborhood outline. With that data piece taken care of, we can then start to visualize this data. So our first step is to use the geometry field coming in from our neighborhood data to draw an outline of all of those neighborhoods. And again, we know that this is going to come in as a single mark. We can separate that out into its component parts by adding a dimension. So we add each neighborhood name. And remember when I said that all of this mapping information is fully integrated across Tableau? We are going to add a second axis into this view to create a dual axis chart. The reason for that is we really want to show each of the individual points for all of our Airbnb locations superimposed on top of this neighborhood map. To create a dual axis map, I'll use the Control key to build a copy of my generated latitude field and add that out on rows. I now have two maps that I can work with. I also have two marks cards, one for each map, and then I have a final marks card called All. Any changes I make to the All marks card will be applied to both maps. Any changes I make to one of the individual map marks cards will apply only to that map. So I'll take off the fields that came from the duplication process. And instead of working with the collect field from our neighborhood information, I can add the latitude and longitude locations for Airbnb listings. And we get a single listing for all of Boston. What's happening here is Tableau is aggregating all of the latitude and longitude values across all of our Airbnb rows. So we can start to break that down by adding the individual ID for every property. To make it easier to look at, I'll make the size of those circles a little bit smaller and add some contrast by making them orange. And now I can create a dual axis map just like I create a dual axis chart by applying the dual axis option on the measure. I can take this a step further though. Every Airbnb listing has a URL. If I add that URL information into the view, I can create a dashboard off of this. And that dashboard will have the view that I just built showing all of my Airbnb locations superimposed on top of my Boston neighborhoods. And it will contain a web page component. I will not add a static URL here. Instead, I'll just click OK. What I will do is add a new action to my dashboard that will jump to the Airbnb listing URL if I click on it. I'll set it to open in this new web page object and jump back to that and have it run on select. So if we think about this process from a business perspective, what we've just done is taken geospatial data from one location and added in plain text data from another location, generated spatial points from that secondary data set, joined that with our geospatial data, and then overlaid that information to create a visualization that gives us the exact information that we were looking for. By adding the URL information, I could then select an Airbnb listing and see that listing data pop up in the window on the right. And it will take just a moment. There we go. Now the data set that I have is a little bit old. And the reason that we don't see the listing here is that Airbnb changed how its URLs are represented. So what's happening is that every unique listing URL is correct as of a few weeks ago. But now Airbnb is forcing it to resolve and search a different set of data. These URL actions are a great way to add interactivity and to add a little bit of excitement and interest. I have had a customer who was participating in genetics research who used a URL action to do something that was not opening up a URL. You can use them to open an Excel spreadsheet, which is what she was doing. She had a number of study participants. Each of them had their own unique spreadsheet. And she used a URL action to do that because she had the full UNC path of that spreadsheet in her data. Other customers have used these to open up a new email message or to start a voice over IP call with somebody in tech support. So they're a great way to add interactivity and functionality and keep people in the workflow of their analysis. The next piece that we'll cover is going to take this a step further and start looking at a couple of things that we haven't seen yet. We've already covered geocoding and customization of territories. We've talked about spatial joins and the make point function. Now we're going to look at more spatial data. Well, kind of spatial data, so that we can start to analyze distance for some shipping routes. And we need to use a calculation for this in order for this to work. This is just a single spreadsheet. And when I said this is kind of spatial data, it really is just a spreadsheet, but it does contain origin and destination city names and latitude, longitude for shipping lanes via plane and shipping volume. Given what we've learned already about creating spatial points off of non-spatial data, we'll use that piece and we'll build on that by using something called make line to actually draw a line between those spatial points that we generate. This new calculation will draw lines, and the make line function needs a single start and end point. Well, we don't have that because this is not true spatial data. So what we will do is use make point to create a spatial point for our origin latitude, origin longitude, and create an endpoint for our destination latitude, destination longitude. I don't need anything except that lines calculation for Tableau to go through and find for every row of data the origin and the destination point, and then draw lines connecting all of those. This looks like it's taking a little bit longer than I would like. So I'll jump back to our example. And we'll take a look here. This is what you would see outside of those fields after we create those lines connecting the origin and the destination points. I've also added the origin and destination city and state names here to give a little context when we go in and modify that tooltip to make it suitable for public consumption. If I add something like volume onto color and onto size, the wider paths are now the ones that are the most heavily used, and the narrower ones are used less often. We can also use a distance calculation, though. The distance calculation looks almost exactly like our make line calculation, except it uses a different function, and it has an additional argument to determine whether or not you want to show distance in miles or kilometers. If I were to put that distance calculation onto color, the darker the color would be the longer distance, and the lighter color is the shorter distance. This is something that's used really effectively to start to plan travel routes or things along those lines. We've got a couple minutes left, so I want to show you one more piece here. Just keep in mind that Tableau can connect to all kinds of spatially enabled data, and this includes a spatially enabled database like Microsoft SQL Server or Oracle or something along those lines. It also includes the ability to connect to spatially enabled data using the Esri ArcGIS server. And there are a couple of ways that you can get to that. You can come to any node in a server view like this and copy the URL of the node that you're looking for. In this case, this service coming in from the Esri GIS service would give me all of these different layers. Each layer is effectively a table that Tableau can work with. Other ways that we can connect to server-based or service-based data is to use a portal like this one. It used to be that we would have to download all of that data, but now we're able to use the GeoService API. And back in Tableau, if I connect to the Esri ArcGIS server, all I need to do here is input that URL, whatever it was that I copied, and connect. In this case, Tableau is going to connect to the specified layer. And on a brand new worksheet, there we go. It's actually retrieving contour information of Hawaii and Kauai. And on that brand new worksheet, I can use the shape field, which is very similar to the collect field that we saw earlier. Break this down by the individual ID. So I have now all of the different contour lines. And if I put contour on color, it makes it very easy for us to see the contours of the islands of Hawaii and Kauai. So there are so many different ways that we can connect to spatially enabled data. There are ways that we can join that data together, and you can use those components to build on the knowledge that you already have of things like filters, parameters, and sets to create informative, interactive, and insightful views based on your spatial data. We're getting close to the end of the hour here, so I do want to leave a little time to answer any questions. So Steve, I'll turn that back over to you just in case we have anything that is unaddressed in our chat.
Perfect. Great job, Laura. That was really interesting. I think we tackled almost all of the questions in the Q&A panel and in the chat. One question from early on, though, and I'm sure we always get this, is with your the data sets that you're using here, are those just in normal files? Is this something that we can share with the attendees if they wanted to open it up and take a look at it?
That, Steve, I honestly don't know. These are normal files. None of this is proprietary data. I have a workbook and I have the data that we could make available. Steve, do we have a way to do that?
Yeah, so perfect. If you can send that to me, and everyone, if you're interested in getting your hands on this workbook with the data, um, this is super dangerous when there's 300 people, 400 people on the call. But shoot me an email and I will send it to you. I'm going to put my email address in the chat window.
Hey, Steve, there might be another option.
Yes, what is that?
I believe that this data is available at one of the recordings that Ashwin did of this presentation.
Oh, you are correct. So let me get that link real quick and I'll put that on the in the window. Hold on one second. You're right.
So I have that on the screen, and if you go through the process and actually watch the video, that might mean that you have to click on the watch now, but there will be an option there to download the data and the workbook.
You're right. So can you put that URL into the chat window for everybody?
Absolutely.
And then, so this will require, this is a great recording from Ashwin, our product manager for Maps. Pretty much the same content that Laura just went through. So you could probably bypass watching the video, but down below the video, once you log in to view it, down below the video, there is a place where you can download the workbook and the data for you to play with this.
The great thing about this, Steve, is in that video, Ashwin gives his email address. So if anyone has any questions or if anyone wants to see an additional database that we don't yet support for geospatial data, he invites those questions.
Great, I love it. All right, so I think that was the bulk of it. We did just have a question pop up, yeah, and I'm not sure off the top of my head. Is there a way to display points and lines and filled polygons all on the same map?
Yes. So if we think back to the example, let me find it here because I have several copies of workbooks open. If we think back to this example where we are showing lines, these are actually going to and from spatial points. We could create a new spatial point calculation that would show the origin and destination points individually. And then we could display those points on the map. And we could use the dual axis technique that we saw earlier to overlay the points and the lines on top of polygon data.
Perfect. That's great. All right. Well, I think that is the last of the unanswered questions. So everybody, thank you so much for joining us for this Tableau Tuesday. Hopefully you found it uh, uh, instructional, educational. We will have this video up on our YouTube channel later this week. Again, it's youtube.com/c/Tableau Tuesday. I had the link in the chat as well as in the Q&A at some point. But go ahead and click on that. It's also, if you're hopefully you're using the invite that I sent out to everybody, it should be at the bottom of your invite, a link to our YouTube channel. So uh, thanks for the great presentation, Laura. We really appreciate it, and we'll see everybody next month on Tableau Tuesday. Thank you.
Thanks, Steve. Thanks, everyone, and happy mapping.